Hi, Algebra 1 students. Today we are going to be learning about interpreting graphs of functions. So our lesson objectives for today are to interpret intercepts and symmetry of graphs and functions, as well as to interpret the positive, negative, increasing, decreasing behavior, the extrema and end behavior of graphs of functions. So make sure those are in your notes. So first, when we interpret graphs, let's look at some key points on a graph. First, we have the intercepts. Now, the intercepts of a graph are the points where the graphs intersect on the axis. So the axis is our x-axis and our y-axis. The key points are the x-intercept and the y-intercept. If we look at this first graph, our x-intercepts are here at 0 and right here. And our y-intercept is right here. This graph here, we have x-intercepts here at 1 and another one at 5. And our y-intercept is at -5. And if we look at this third graph, we have an x-intercept here at 3 and a y-intercept at -3. The second important feature that we want to look at today is called the line of symmetry in the y-axis. This first graph does not have any symmetry. If we were to flip it along a y-axis, there is no point on this graph where it would mirror side to side. The second graph does have a line of symmetry. If we flip the graph along this line, it is the same on both sides, so that would be considered a line of symmetry. And again, the third graph, there is no line of symmetry. So make sure you have these two in your notes, intercepts of the x and y, and also a line of symmetry. Next, let's look at some function behaviors. So there's a few different function behaviors that we want to look at. The first one is the positive and negative. So a function is positive when its graph lies above the x-axis and is negative when it lies below the x-axis. For example, if we look at this graph, we see here that this is positive, and then it becomes negative, and then it's positive here again. And on the second graph, we see it's negative until here, and then it is positive. So think along the x-axis. Anything below is negative and above is positive. The next function behavior we want to look at is decreasing and increasing. And in this time, we want to look at kind of the slope of the graph. So here we can see that it is decreasing, 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 and then it hits a point where it now starts to increase. And it will start to increase along that. The second graph is always increasing. So remember to look at it from left to right. If it is decreasing, or if it is going from positive to negative as you go from left to right, then it will be decreasing. If it is going positive from left to right, then it will be increasing. Another function behavior we want to look at is the extrema, which is locations of relatively high or low values in the function. For example, we have these points that are a relative minimum and a relative maximum. Those are extrema. In this graph here, we have a relative minimum extrema. This graph does not have any relative minimum or relative maximum. The last behavior we want to look at is end behavior, which describes the values of functions at the positive and negative extremes in the domain, which, as you recall, is the x-axis. So as you move to the left, the graph goes up. Y increases and x decreases. So we could say that in this case and in this case, y increases. y increases, and y increases. As x increases, though, you'll notice on this graph, we could say that the end behavior as x increases, y decreases. Whereas on this graph, the end behavior as x increases, y increases. Again, if we look at this graph as x decreases, y decreases, and as x increases, y increases. Let's now look at a few functions that have been graphed. First, we want to identify them as linear or nonlinear. In this case, since it is not a smooth straight line, this is a nonlinear graph. Next, let's estimate and interpret the intercepts of the graph. We see here that the y-intercept is 0, and our x-intercept is 0, around 3.2, and 4.8. There does not appear to be any symmetry in this function. Here we can see the function is positive here, and then it goes negative, and finally goes positive again. Then we can look at whether it was increasing. Here it is increasing. Here it is increasing. And where it is decreasing. Next, we can locate the x-coordinate of any relative extrema. We see that the x-coordinate is x equals 2, x equals 4, and the end behavior of the graph. So it appears that as x is increasing towards the right, y is also increasing. So that is how we would identify the behaviors of this graph. We can also look at it from what it is describing. So we see here, this is a stock that is selling on the market, and we see that initially it gains value for the first 2 hours that it is opened, and then it decreases in value for the next 2 hours till it has actually lost value throughout the day, and then it is again increasing as the day goes on. So that's a very simple example of how stocks may fluctuate in value over the day. Now here's another example. Go ahead and try this first on your own. So let's identify it as linear or nonlinear. We can see here that it is nonlinear because it is not a straight line. Then we can estimate and interpret the intercepts of this graph. This graph does not have any x-intercepts. The y-intercept is equal to 60. See if there is any symmetry. We notice that there is a line of symmetry here at x equals 16. We can notice where the function is positive. We'll notice here that it is always positive. It never goes below the x-axis. When it is increasing, we see here, it's increasing, and then it's decreasing on the left side of the line of symmetry. The x-coordinate of any relative extrema, we see here, the x-coordinate is 16. And the end behavior of the graph. So as x decreases, y increases. And as x increases, y also increases. One last example, again, go ahead and try this in your notes. So here we see that this is a linear graph. We can estimate, interpret the intercepts of the graph. Here we see that at around 45, we have our y-intercept, and our x-intercept is at about 5.5. There is no symmetry. Where the function is positive, we can see that it is positive until the x-intercept, and then it goes negative. It is always decreasing. And there is no extrema. The end behavior of the graph we can see as as x decreases, y increases. Y increases. And as x increases, y decreases. We can see that by looking at the endpoints of this graph. So we see here, as we follow this to the end of the graph, x is decreasing. X is going from 2 towards 0 to -1, and y is steadily increasing. And then as we go the other way, x is increasing from 2 to 4 to 6, and y is steadily decreasing. Thank you all for listening. The homework that is due for next class is the 1-7 practice problems. And the next class we will be reviewing for our summative exam. If you have any questions, please feel free to email Mr. Schuessler or drop back into the Zoom call if it's still on. Thanks for listening. Bye for now.